To define the member function show outside the class, the format is return type, class name, scope resolution operator, followed by member function name, signature if any, opening and closing curly bracket. Now in order to write the code for show, two cases are there. Case 1, f less than or equal to r. This is the figure for f less than or equal to r because you can see f is 3, r is 7 and 3 is less than or equal to 7. And case 2, f greater than r. This is the figure for f greater than r. You can see that f is greater than r because f is 7, r is 2 and 7 is greater than 2. Now to write the code for show function, the first point, if the circular queue is empty, just display the message empty. So if f equal to -1 and r equal to -1, meaning circular queue is empty, you cannot display the elements, so simply write empty. Else you can display all the elements. Now the speciality of circular queue is visualized in the form of a circle, which means the starting point or the first element and the ending point, the last element, should be separately displayed, and only after that all the elements must be displayed. Okay, so how do you get the first element of a circular cube? F contains the index of the first element, so your first element is CQ of F. Similarly, R contains the index of the last element. So this last element is nothing but CQ of R. So you can write first, the first element is CQ of F and the last element is CQ of R. Now two cases are there to be considered. Case 1, F less than or equal to R. So if f less than or equal to r, how can you display all the elements? You can see that from index 0 to index 2. Now how can you generalize this? If this is f, certainly this is f minus 1. So from index 0 to index f minus 1, elements are not there. So let me write the code for this one. 0 to f minus 1, elements are not there, which means you can write for I is equal to 0, I less than or equal to f minus 1, I plus plus, elements are not there. See out output operator dash, meaning no elements. Okay. Now this variable I should be declared int I. Again, you can see from index f to index r, elements are there. So how can you write the code for that? For I is equal to f, meaning this one, I less than or equal to r, meaning till this point, I plus plus. Now I contains this index, so initially I is f, then I becomes f plus 1, then I becomes f plus 2. So I contains this index, so the element will be CQ of I. So you can write cout output operator CQ of I, and after displaying one element there should be space. Otherwise the elements will appear together. So after displaying one element there should be space. Again, if this is r plus 1 and this is upper bound size minus 1. So from r plus 1 to size minus 1 upper bound, you can see elements are not there. So you can write the code like this. For I is equal to r plus 1, meaning this one, I less than or equal to size minus 1, meaning this, I plus plus, elements are not there. See out output operator dash. Now associated with the if, multiple statements are there. So you need the opening curly bracket, closing curly bracket. Now else, meaning case 2. So in case 2, you can see that from index 0 to index r, elements are there. So let me write the code for this one. Index 0 to r. So you can write for I is equal to 0, I less than or equal to r, I plus plus. Now I contains this index. So this element will be CQ of I. So you can write cout output operator CQ of I, and after displaying one element there should be space. Again, if this is r, this is r plus 1. If this is f, this is f minus 1. So from r plus 1 to f minus 1, you can see elements are not there. How will you write the code for this one? You can write like this. For I is equal to r plus 1, meaning this index, I less than or equal to f minus 1, meaning this index, I plus plus, cout output operator dash, elements are not there. Again from index f to index upper bound size minus 1, elements are there. So you can write like this. For I is equal to f, meaning this index, I less than or equal to size minus 1, meaning this one, I plus plus. So I contains this index. So this element will be CQ of I. So you can write cout output operator CQ of I, and after displaying one element there should be space. Now associated with the else, multiple statements are there. You need the opening and closing curly bracket. Similarly associated with this else, multiple statements are there. So you need the opening and closing curly bracket. So this is the definition of show for circular queue. Now in order to study this code for the exam, easy method is there. No need to go through this diagram. One easy method is there. F less than or equal to R. You can remember the code based on a number line. You draw a number line. The starting point will be 0 and the ending point, it is upper bound size minus 1. Now F is less than or equal to R. So F should come first followed by R, because F is less than R. Now as you know, if this point is F, this is F minus 1. Similarly, if this point is R, this is R plus 1. Now elements are always from first to last, which means here the elements are there. So that here the elements will not be there, and here also elements will not be there. So from this number line, easily you will get the code. You can see that from 0 to f minus 1, elements are not there, and it comes here. I is equal to 0, I less than or equal to f minus 1, I plus plus, cout output operator dash, meaning elements are not there. Again from f to r, elements are there, and it comes here. I is equal to f, I less than or equal to r, I plus plus, elements are there. So CQ of I, output operator space. Again from r plus 1 to upper bound, elements are not there. So from r plus 1 to upper bound, elements are not there. So this code easily you can study based on this number line. Similarly for the else part, f greater than r, let me draw the number line. The starting point is 0, the ending point is upper bound. Here f is greater than r or r is less than f. So r comes first, followed by f. Now if this point is r, this is r plus 1. If this point is f, this is f minus 1. Now elements are always from first to last, which means here elements are there, here also elements are there, and here elements will not be there. So here elements are there, and here elements are not there. Now from this number line, easily you will get this code. See, from 0 to r, elements are there. So from 0 to r, elements are there. So CQ of I. Again from r plus 1 to f minus 1, elements are not there. So from r plus 1 to f minus 1, elements are not there. Dash. Again from f to upper bound, elements are there. You can see from f to upper bound, elements are there. So CQ of I. So for the board exam, study this code based on this number line, and this is the code for show function associated with a circular queue.